Rick with Rick's Toy Room, and after posting my neon signs that I built, or the LED neon signs I built, I've had a lot of questions on how to do it, so I'm going to give you a quick tutorial on doing the modeling, and then we're going to go back and do another video that does the actual wiring, okay? So first things first, you're going to want some kind of design software. I use Fusion 360 or Autodesk Fusion, whichever version you've got your hands on. Go ahead and create yourself a new sketch. I like to layer myself out to the top view. I want to do a new sketch, so create sketch, pick that top plane or the bottom plane so that I can see the top view. And then what I do is I set my build plate size. So I'm going to do create rectangle, center rectangle. I'm going to go right into the center of the grid, give me that little blue box around the circle, kind of stretch out, and key in my 220, hit tab 220. This is my 220 build plate, finish sketch. That shows me the actual space I have to build this neon sign. Now there's a couple different ways you can do these. I like to just go to Google, type in neon sign, and then whatever it is I'm trying to design, whether it's a Batman logo, the Halo logo, the LA Dodgers, this is going to be the USF. So I did a quick Google search of USF neon sign. I found one that I liked. I downloaded it, and now we're going to insert it. So insert canvas, and we're going to go insert from my computer, and grab the canvas. It's going to ask where to put it. I want to put it on this bottom flat plane. It puts in the image. Now, normally this is really, really small. Because I actually have this open on another window, it gave me this bigger full size. What I want to do, though, is I want to stretch this out, and I want to get the green line as big as I can get it to fit my build plate. The reason I'm leaving the white out is because I want to do this as a single neon color for the moment. It'll be easier to do this tutorial. And I'm going to build this as a white frame. So I'm still going to get that white and green. So I stretch this out, and now I have where the green neon will fit my build plate of 220. Now what you want to do is you want to draw the outline of this neon. So you want to draw this entire little green neon. Easiest way to do this is create sketch. On that bottom plane again, do the create button, choose spline and control point spline. You're then able to click at the dot or click to create a dot, and then it'll stretch the line for the next dot. And you're going to put as many dots as you need till you get this whole thing outlined. To save us some video time, I've already done this in another window. As you can see, I have all my little dots. When you get the dots finished and connected, you get a solid blue line. I'm going to hide the canvas. And now I have the outline design of my neon. This is where the neon rope's going to run. This is going to make the design. Now we need to create a track. So let's zoom in on this bad boy just a little bit, kind of center it. And what I'm going to do once I have the neon, I have the outline selected that I want to build my track from, I'm going to hit E to extrude and choose this thin extrude. And the reason we're going to do this is the fastest way I've found from all the tutorials to build a track. So I click thin extrude, I click that line again. It gives me my distances with the neon lights that I used, and I'm going to post these in the description, but these are 12 millimeters high by 6 millimeters wide at the cap, but I'm not using the caps. We're building our own track, and I want this what's called friction fit. I want it just tight enough where it fits in, not so tight that I can't squeeze it or that I'm going to break it, but at the same token, it's not going to fall out if I turn it upside down and shake it. There's no glue, no adhesion. This is friction fit. I know by measuring it with my calipers that it's 4.9 millimeters wide, and the height is actually 12 millimeters from the very top of the neon to the very bottom of the neon. But I want it to stick out from my base a little bit. So the two things I'm going to do is I'm going to make this wall shorter than the neon, and then I'm going to put in a bottom layer that it's going to sit into so it doesn't fall all the way through the sign, and it gives me this like nice sturdy holder, and I don't have to worry about all kinds of little like tabs and stuff of losing the neon. So first is your distance. This again is your height. For this particular model that I found, this rope, it's 11.7 is how high I build my walls. I don't do a taper angle, and I'm going to do the full thickness of 7.2 millimeters. So what this is designing is it's designing the distance between these two walls of the track. So this entire distance is 7.2 millimeters from edge to edge. And you're going to do this from the center line. So this is going to follow your track or follow your design. It's going to center the track. It's going to make sure the edges are completely even. And now I'm going to hit okay. Now, as you can see, we've built the actual neon sign. This is this, okay? But we got to cut this out of the middle. So what you're going to do now is, again, you got to bring your sketch back, because once you do a extrusion, it hides your sketch. So you click this button, bring your sketch back, find your center line, hit E to extrude. Again, we're going to do a thin line extrude. We're going to pick that inside track. There we go. As soon as you pick the inside track, it brings up all the measurements. I found that doing it in this order works, so do this. First, switch to your center. Second, we need that 4.9 millimeter width that's going to get cut out. Next, we're going to do our distance of 11.7, which is going to do that height. Change pink, showing that we've got this cut out. But what I want to do is I actually want to do an offset. So if I choose offset and now do 1.8, what that's going to do is when I hit cut, it's going to put in the bottom portion of this track. So if you just wanted to print just the frame, you don't want the extra size, you don't have this extra logo line, whatever, you can just print just like this right now, and that's going to be your frame. Drop in your neon, put your holes in, you're done. What I'm going to do now that I have that built is, again, we built our track. We need to start planning some design items here. So first things first, this is going to be a single color neon. So I only need one hole for the wires to come into. And because I'm only going in and I'm going to solder in one side of the neon light, I need one hole, and that hole needs to be about 4 millimeters wide. So I'm going to go right down the middle, just kind of eyeball this. I'm going to create a new sketch. Now you should be able to do a hole here. If I just do hole and eyeball it, like I said, I want it to be on this plane, and this is really the center of the actual design, but put that hole where I didn't want it. Let's take that hole, let's make it 3 millimeters. I'm gonna target, shut up. All right, I'm over that. Create, I want to create a sketch, and I'm going to do it right here on this body. Move it around so I can see it. And again, I kind of want it just to come out of the center, even though this is the center of the actual, oh yeah, I guess that's going to work, because when I hang it, I can hang it. I don't like that spot. Yeah, okay, we'll do it. So we're going to put it right there in the center. I'm going to click right here, create a circle, right down the middle. Let's set that 4 millimeters. And now I can click inside, I can hit extrude, and I know that right now that depth is 1.8, so I'm going to set it to 2 millimeters. I'm going to do a cut, and I actually think that needs to be, yeah, it's going the wrong direction. So -2 millimeters. And there we go, it comes out the bottom. Let's just make it -4 for, know that we're going to go through, hit OK, and presto, now we have a hole. Again, the only reason we did a 4 millimeter hole is because 4 millimeters is going to be plenty of space to get your wires up through the bottom, solder into your neon, run your neon, and done. With a single color, that is perfect. If you were doing multiple colors, there's going to be a problem here, or multiple sections even. If I had a whole second track, so like the Batman logo, right? I have one track that runs the bat, I have one track that runs the outside circle. I have to have enough space in this hole to run a set of wires in to solder to the neon, then back out to come out the back and go into the hole for the track that then will power this neon. So I try to keep these designs as clean as possible. There's 10,000 different ways you can do it, but this is how I do it, and it's just easy for me. So that single hole, the last thing I want to do is I want to give it a nice solid base, because again, I can print this just as is, and you're just going to have this nice little frame of the logo, but that doesn't give me anything to attach to. I would have to, design hooks and all that. I don't want to do that. So the next step I'm going to do here is I'm going to go into this center area that is basically handled by the design that we've already done in our extrusion. And I'm going to take that area. Oops. Let's get rid of this. I don't need that sketch anymore. So let's just, I'm going to delete the square sketch. I no longer need the size of my build plate. There, now it's not aggravating me. I'm taking this negative space and I want to make sure I'm on the top. I am. I'm going to extrude this and I'm going to do, I do this layer at 4 millimeters. And I want to do it, I don't want to cut. I'm going to take it out the bottom. So let's do -4. And it wants to be a join. Why is, oh, that's 44. Oh, that's no good. Negative. What in the living squat is it doing here? 4 meters. No, 4 millimeters. There we go. And that's going to build me the bottom base. By doing join, it's going to connect it to the remaining portion of my prints. The only thing is I also need this area extruded out that 4. So let's do this. We're on the back side now. There we go. So that should do it. That is not what I'm trying to do. I want this whole area. There we go. Flip it to the back. Select the back of your design, and then control click this empty space that gives you both this area. That's why it's highlighted in blue. Extrude, and now let's set it to 4 millimeters. And we're going to do a join. And what that now did was built us a base that has a total size of 1.8 millimeters plus 4, so 5.8 millimeters. I'm going to go ahead and hit OK. And now I have the entire internal design. It's going to cover punching that hole, which for some reason the hole didn't come all the way through. So we're going to have to recut that a second. No big deal. Just come here, extrude, -6 millimeters. Cut. There we go. Holes back in. You could do the hole later. Probably should do the hole later. As you can tell, I'm not a fusion expert, but this gives me now the backer frame. I don't have to worry about this. I have space now where I can. I have space now where I can hook up 3M tape, or I can create a keyhole, whatever I want. 3M tape works. I use the command strips. It holds these things really well. Now I'm going to save it, and I'm going to throw it on the printer. Should take me about 2 hours-ish. So go up here, and why wouldn't it let me export? There we go. Okay, so we're back. Here is the USF done, ready for neon. Very simplistic design. I mean, if you think about the old neon signs of, the day, you had glass tubing that was shaped, filled with gas that would illuminate when you added electrical current, and then they would plug those in, and you would just have these very, very thin lines of neon, where now we at least have this nice little frame. Here is, in reference, the Batman that we did, and as you can see, instead of being, this way, it's this way. So the 220 by 220 build plate gave us essentially a sign that is just about 9 inches wide, and overall height about 9.5 inches. So not terrible, not terrible. So now that we've got it printed, we did the model. I did one thing that I did not do on tape or on the video, and that was I went in and I did fillets to these really sharp edges. So the reason you want to do that, and you can see here, is that when you put in the neon or the LED tubes, you don't want super sharp corners. Okay, you really don't. You want to try to keep them as curved as possible, and you want to be able to not flex the neon too much, because you will break this. So let's get into this. This one again is a single track, single color, 1 point of entry for the power, whereas the Batman was 2 tracks, 2 points of entry for the power. You can do as simplistic or as complicated a design you want, as long as you're willing to put in the time and effort to do all the wiring. So this is where it's about to get kind of a pain in the neck. It's not difficult, but it is not really easy either. A single color with single line is 10 times easier than doing a multicolor multi-line, and you're about to see why. So here is, again, the neon LED light strip that I ordered. Inside the box, they come with the 5.5 or the 12 volt, 5.5 amp, 12 volt, 5.5 amp or 5 amp DC power adapter with cable. Some wall clips for if you were to actually just do the neon. The barrel connector that will plug into the DC, and then this little end cap here to keep you from touching the electricity, and then these clips go here, and this is what adds in the 6mm. We don't need those. We don't even need this. But how I would do this particular piece, because it is one color, one cable, first what you want to do is measure out your cable, or I mean, you've got a couple different ways you can do this. I'm going to use all the parts from this box for this LED, for this neon, because I'm only doing one neon light. So, a couple things to know. You can only cut these where you see the dark black dots. So I don't know if the camera is going to be able to pick them up or not. But here's one, like right here. Yep, there's one black dot there. There's a black dot here. There's like 8 centimeters, I think they said, in between each dot. If you cut this in between or off of those dots, you're going to damage the diodes that are on the LED strip, and you're going to knock a section out. Luckily, when I've done this in the past, you only knock out that one section of diodes. So if you do actually bust one of these right here, right now, you could cut it out and skip to the next section. What I'm going to do is, I've done a few of these now. I'm going to show you this, but then we're going to do an easy way. I want to use this barrel connector because I didn't, like if you were to buy this online, it already comes with it, no reason to mess with it. But you can tell this is not going to fit through there. Well, I don't want it to anyhow. So first thing I'm going to do, take me a cutter, and I'm just going to clip this end right off. Because I don't need this. I don't need the sheathing. Here is the cables that are already soldered into this. You could mess with and pick all of this glue out. I'm not going to. I'm actually just going to go ahead. I'm going to find the first black dot. I'm going to go right down the middle. And actually, I need my bigger scissors. And I'm just going to cut that dot and cut through. Okay? Take this piece with all the little rubber glue, get rid of it. I'm going to have enough leftover rope light. I don't need that little piece. Now, what you'll see in here is there is an LED strip inside this rubber sheathing. And where that black dot's at are the 2 copper pads we need to solder to. So, what I want to do is I want to expose this cable. Before I do that, I'm going to see how much of it I need for the track. So I'm just going to take it. You want to be super, super careful because again, you bend this like completely, like straight fold it in half, you're going to break this wire. So with all these sharp points, there is a lot of potential here to snap this thing and ruin this wire. So I'm going to just drop it in, and it doesn't matter if you go this way or that way. I normally go this way just so that I've got the solid white backing on the outside. So I'm going to drop it in. And as you can see, again, this is friction fitted. So it lays in there, slides in real nice. And it's not going to fall. Well, it fell out because there's more weight on the end of it. But let's get some in here and I'll show you it's not going to fall out. So we're going to go ahead and run this in here. And just keep very gently go around your corners, go around your edges, and when you do this, what I want you to pay attention to is make sure that you've got it lined up into the track before you push it down. Because if you try shoving this in and you're not lined up and you get the rubber sheathing caught on the edges, you're going to snap the diodes. And trust me, I've done this a couple times already. So let's just keep around the edges. Now, you don't have to treat it like super, super fragile, but you don't want to manhandle this. This bend here is going to cause me a problem, I think. There we go. All right. And don't push it all the way in. Just get yourself worked up where you've got a bit of it running, and then you can push it down and solidify it in. Oh, yeah, I guess I could. All right. We'll get this piece done a little bit later, like when we actually go and get the soldering in.
That way I'm not ruining this. And you can see where this is starting to bind here in this corner. So you don't want to, again, just take your time with it. You're in no hurry. Get the bend done. Get yourself some slack. Keep feeding it. And once you have it all fed in, then you can really kind of like level it down, squish it in, feed it through. And we're already halfway there. It's coming along real nice. Get around this corner. Come back around here. And you want to absolutely have a lot of slack in the cable so that you can do these like little curves and corners and not get a lot of binding. And like I said, you don't destroy your LED. They're not like overly expensive, but they're not really cheap either, and you don't want to waste it. So just take your time, be careful with it. And we're almost done. Last couple bends. And don't push this all the way in because you need to, all we're doing here is getting the measurements for where we need to cut. Okay, so I've got it all the way around and we can see that it's going to end right here. What I want to do is see where the nearest black dot is. And this one is actually going to black dot right past where it actually meets. And we're going to have this space here where we got to get the wires to run through. So what I'm actually going to do is I'm going to cut it at that black dot where I have this extra run. And I'm going to show you how we deal with that. So let's go ahead and just put our finger right there. Loosen it back up. Cut her right down the middle. And snip, snip. All right. There we have it. Now, all this is extra neon out of this box for this rope, for this sign. So this we're going to absolutely use to either make more of these or we'll do something, do another pattern with the green. Keep that. Now, we need to solve for this. So what I've done is I'm actually going to cut a slit right here on the top solid white part because you can see the actual LED is there on the bottom side where the stripe's at. I'm going to run a slit from here all the way past the black dot that we didn't cut, almost to the third black dot. And the reason for it is a couple reasons. One, it's going to allow us to get this LED strip out of the rope so that we have an easier time to solder. And two, it's going to give me some space to maneuver and clip this where we can hide the wire. So you saw in the Halo ones where I didn't clip or I overclipped the neon rope and the wires are exposed. But you've seen in the Batmans where the wires aren't exposed. And the reason for that is how I'm going to cut this. So again, I'm going to just take my snips. I'm going to come right down the middle. And I'm just going to go all the way down a couple dots. So we're going to go past the first dot where we're actually going to cut the light again. So we're going to lose 3 diodes in this because it's just not going to fit in our design. So let's cut down the middle. And it doesn't have to be a perfect down the middle cut. It's going to be, all these cuts and all this damage are going to be hidden inside the track, which make it really, really nice. So let's go ahead and snip, snip, snip. Okay, so as you can see now, I can open up the rubber housing, sheathing. I see the copper lines where I cut it already. The set of diodes, the copper lines. This copper line here, this is the one we're actually going to leave because this is actually the one we're probably going to solder to because I have it out. We've already stuffed the side of the corner, so we'll solder to these. But this here is too much LED. There's not enough space to make this fit. So we're going to cut it at this copper wire here, and we're going to solder here. But I need to remove more material to get to that. So let's just keep cutting until we get to the next set of copper pads. And you don't really have to go to the copper, but I found over the last few lights that I've done that it just gives me way more space to operate. Okay, so where we cut it, this is the one where we're actually going to be able to cut and solder to, because that's going to give us enough space. So let's go ahead and do that right now. just cut right down the middle of these copper pads. Try to make it a nice straight even cut, which I did not do. But don't overcut this where you don't have enough space to solder to, which I kind of almost just did. I needed my bigger scissors. I messed up. Okay, there we go. Cleaned it up. So now we have a fairly straight cut with the copper pads that we're going to solder the power to. It's going to fit back inside here when we're done. And this piece here we're going to be able to use to cover up when it's down. I'm going to use this extra top piece here, and I'm going to use it to cover the wire. So let me solder. Well, before I solder to this, we still need this to go through the hole, okay? And with the sheathing on this, I don't know, is it going to fit? 4 millimeters might be a little too thin. No. So 4 millimeters is not big enough for this sheathing. Easy solution. I'm going to cut the sheathing. The last time I did this, I actually cut all the sheathing off. We don't really need to do all of it. We just need enough to get the wires through and soldered. So I'm just going to strip the sheathing off of the barrel plug. And yes, if you were using a much bigger 3D printer where you can make much bigger signs, you could have made this scaled up in size to make it fit the still with only the 4.9 millimeter track and made a big enough hole to shove this whole thing in there without having to cut anything. But we use the FlashForge Adventure M5, which doesn't have that capability of being that large. So I may have to just go get my real scissors or my box cut or my actual. Oh, I got a box cutter in here. You know, I could use wire strippers, but that would require me leaving the office right now. Here we go. That's better. Yeah, see, look, I'm no professional. I can do this stuff. All y'all can do this too. I mean, I know I've seen a lot of how-to videos where you got these guys that look like they've been, you know, doing electronic engineering for, you know, years and years, and their desk is filled with, you know, all the right tools and soldering microscopes. And hey, look, man, I'm basic, okay? I'm your average guy that got a 3D printer. There we go. So we got the sheathing cut. Now the wires will go in from the back. Doesn't matter how you push them in there. They just got to go. There we go. They're up. That is more than enough for me to solder to. Now, if you wanted to make yourself way more comfortable, you could cut more sheathing and make more space. I don't need that much. I don't need that much room. Oh, I lied. I'm going to need way more room because I got to get that cable to this LED. So let's remove some more sheathing. At this point, I'm just about to strip it completely off, to be honest. And then once we actually get it soldered and pushed back in here, we'll just make it whatever size we need. I mean, normally I just do this with a pair of kitchen scissors and call it a day, but I'm not in the kitchen, I'm in my office. All right, that gives me enough space to work. Yes, plenty of space to work. Okay, so now how do we do this wiring? So this being the factory barrel plug, the first time I did this, I stripped it out so I could see exactly how they soldered it to the strip. And that's very important because what you need to know is on this strip, there is a marking up here at the top that says plus 12 volts and then just a negative down here for ground. So the red is your positive plus 12 volts and the black is ground. So what I know is red goes on top, black goes on bottom. And actually, I just now realized this. Positive and negative are on the back of the strips. So plus 25 or plus 12 volt on top, negative being the black on the bottom. Typical kind of like a standard wiring instructions. So let's strip these bad boys out. You know, I don't like the idea of doing soldering on my really nice office desk. So I've actually set the soldered iron and gear back there on one of the print benches. So that's where we're going to go to solder this up. As soon as I can get this flipping cutter to strip that wire. There we go. Goodness gracious. And you don't need a lot of wire stripped off here. You need just enough to pre-tin. There we go. You can see the little copper exposure. I'm going to go tin these real quick. These are a braided wire, so you're just going to kind of twist them together so you can pre-tin them. For those of you that don't know what that means, it means you're going to heat up the end of this wire. You're going to put some solder on it so you have solder on the wire already before trying to solder bare copper to bare copper. So let's do that. Actually, I'm going to take this and I'm going to put 2 blobs of solder right here on the tip of this. So let me go solder this up. I'll be right back. Where did I leave the solder braid? There it is. Solder. Okay. Just to show this guy to you, real time, that's exactly how long it took. As you can see, I've got 2 little silver blobs of solder right there, and there are 2 silver, that one actually, crappy job, but there is solder on the ends of the wires. So now I'm going to put the red on the 12 volt, the black on the negative. Not to burn this off. So the hardest part about doing this is because this is sitting inside this rubber sheath and it's in the way, it makes it hard to hold if you don't have all the right soldering tools in a proper station. But there they are, real simple. Again, 12 volt goes at the top where the actual neon's at. Negative goes to the bottom white. Okay, so let's put this in here. I just totally screwed up. I soldered this without feeding it through the hole. Let's redo that. Gomer. that that is fed through, and I'm not going to edit that out. I want you guys just to see kind of how time consuming this can be. So what I want to do now is I just want to test to make sure before I actually feed this through that this thing's working. So let's plug this into the wall. Beautiful. All right, working just fine. So now what we're going to do is I'm going to finish feeding the wire through here. We're going to get this thing kind of stabilized because, again, some of this is sticking out really bad. So let's go ahead and get these corners in here and get them. And again, now is the point where you're going to put some pressure on here, and you're going to try not to overly exert. If you start hearing crunching noises, stop pushing. Align your rope light a little bit better, because it should sit in flush with the design. And I'll go back and do some of this as I finish this up. Okay. Seems that this white PLA actually had some shrinking. Now, for this part here, as we're going to feed this through, first thing I want to do is I want to get this light, the LED strip, back inside the rubber. I want to make sure that this is lined up, and there's a small little track on the bottom of this that allows it to line up. Now what you see is we're kind of stuck here, right? I'm going to cut this bottom half off that we don't need, because it's going to get in the way. It's not going to allow us to fit with the way we did our design, because I didn't design a track for the wiring, because I really don't have to. I mean, all right, so what I've done is I've now sliced the excess in half, and I'm going to cut this bottom piece off, leaving us the top to cover the wire. So let's just snip that right here. And again, this does not have to be perfect, because no one's ever going to see this piece. It just needs to be out of the way. All right, so now what you got is a space to put the wires in, a spot to line up the LED back in there. And then line this up, make sure that this is back in its little track. There it goes. And you see it's disappearing. You don't see the cuts. And we're still a little over on this edge. So I'm going to cut just a wee bit, just enough to squish in there and hide the wires. Survey says I might have to cut just a little bit more. Oh, got it in there. Good. And then I'm going to lightly pull on these wires so that this goes in. Finish pushing this into the track. And not all of this is going to go all the way down, because just based on the shape and the amount of stress that you're putting on the strip on the inside. There we go. It's done. You can see that some of them some parts a little uneven. I mean, I can pull this piece back up, kind of even that out just a wee bit. There we go. Just like that. Now, let's cut off the lights, turn it back on, see how it looks. I'm going to turn this a little bit more. There we go. Ta-da! She's done. That's it. That's all it takes. Now, you can take, and obviously I used the wall plug that was already plugged in, but you would just take the power inverter, plug this in, plug it in the wall, throw some double-sided tape on this bad boy, use some 3M command strips right to the wall, and there you have it. So there is my USF Neon. Took me about 30 minutes top to bottom, small intro, doing some soldering fix. When I lit this up, this spot right here, so this 8 centimeters of area where we cut out the LED to make this fit, is darker than the other spots. On camera, you never notice it. On in person, looking straight at it, you will absolutely see it. The thing about that is, though, to be honest, it's not super noticeable because these things are so bright when you're looking dead at them. They, they'll blind you. So you don't want to keep staring at them for too long. So you don't really notice the dark spot. I'm not a big fan of this design just because these really sharp corners make it very difficult to bend this tubing, the rubber casing, and get it in that spot to lay it completely down flush. But I also don't want to shove this down here because I don't want to snap the LED strip that's in here. So that is how you do a single color, single entry sign. If you were going to do this with multiple spots, what you would do is you wouldn't actually stack, or you wouldn't put both corners in. You'd leave enough space, and you may have to actually drill the hole a little bit bigger or 3D print this hole a little bit bigger. On the Halo, I actually printed a like a rectangle that you can actually fit in all the wires. Because what I like to do is I like to try to keep the entry points very clean. So I come in with power on one end, feed it through till where basically it's going to terminate the power to go to the next location. Feed those wires back out the same spot and then go into the next entry. So you see that again on this Batman. On the Batman, there's 2 spots. There is the hole that is right here that the main power comes into and then goes back out of. And this is why it's got a much bigger hole here than there is here. Because I have 2 sets of cable that got to go through this hole. I have the power comes in. So power would come in here. It would wire to this end of the LED, or maybe this end, whatever. Feed the light all the way through these spots, come back. This set of cables then connects to the other end of the wire. Those cables come back out here to this hole, enter back into the print to now one of the 2 sides of this strip. As soon as power's added here, feed it in, done. And that is how you can feed multiple power lines without it being on the actual display. Now, if I had a bigger printer, I would actually do a shell that would encompass the back of this so I could put the shell here and hide all the wires. But all honesty, this one little wire coming out the back by the time you run the power is not going to make that big of a deal. You don't see it. It's a much cleaner design. And again, even on this, you see it's a much cleaner design. You don't see the wires. That's why the reason I use this filler, because I can run holes anywhere else in this track and run an exit line to hook up the next part. And you just keep adding, clips and clips of wire until you're done. The one thing I did not do was I did not count how many sections this is, but I can tell you right now, this looks about as much as I did on the Halo lights. I could probably get 3, 4, maybe even 5 total USF designs. This design out of this rope light. This rope light was $17.99 plus tax, so that gets me the rope light, it gets me the barrel plug adapter, and it gets me an AC adapter for one. If you were to say, okay, I want to use the rest of this now for either multiple of those so I could sell them at shows, or I want to make another sign using the green, all you have to do is just make sure that you're at a dot where you have the copper leads here, which this one has plenty of copper. We did not cut into one of the diode strings. So you would just solder your positive to the top, your negative to the bottom. measure it, feed it, cut it at the spot, redo that step. The AC adapters, or excuse me, the DC adapters by themselves are $5 each on Amazon. I'm going to put a link to these in the description of this video. I'm going to have a link to all the different colors of the light that I used. The DC adapter comes with the wall plug, the DC adapter, and the male barrel plug. The barrel plug is 5.5 millimeter by 2.1 millimeter. So the diameter of the plug is 5.5 millimeter. The ground pin on the inside is 2.1 millimeter. And you can buy a whole pack of just the barrel plugs for $8 for 10. And you just basically buy it comes in it comes in a pair, so you get 10 of the female and male ends. You won't need the male ends because you're buying the AC or the DC adapters. So you just basically grab all these out, get yourself the extra DC adapter, plug them, wire them, and make multiple lights out of your $17 bundle. And that brings the cost down to, let's say we can get 4 out of this for $18. That's roughly $4.50 in LED neon. It's another $5 for the DC adapter, so you're at $9.50. Another, just round up to $1 for the barrel plugs. You're at $10.50 to make a neon sign with a single color. Now, if you want to do multiple colors, you could get one option is you could have done this in a multi-programmable neon LED strip. Why? It's supposed to mimic a vintage neon sign. One color, Batman, is yellow. If you're doing like a peace sign, or if you wanted to do your name, and again, you're going to do all those things the exact same way. Like if you wanted to do your name in neon for your office, go back to the video, drop your 220 by 220, design plate, sketch out your name, extrude it, print it. Hook up it's $22 for the multicolor that have the little remote control where you can change the colors, do patterns, all that crazy stuff. Wire it up exactly the same way, and then there you have it. You use your remote control, have your name, do all kinds of colors. If you want a video on that, we can do that. That won't be a problem. I'm going to put the Batman design, the Halo design, the LA Dodgers design, and the USF design up on Cults right now, and then I'm going to put the links so you can buy these if you don't want to do your own modeling. You can go to Amazon, use my links, buy your neon LED strips, buy extra barrel adapters, buy extra power adapters, and start making signs. So hopefully you enjoyed this video. I know it was a little long. It's about almost an hour between this edit and the 14 minutes we did for actually doing the modeling. If you have questions, feel free to reach out to me. You're probably watching this from a link that you saw on Facebook, or maybe you're a subscriber of my YouTube channel. Reach out either here on YouTube, on Facebook. I will more than happily walk you through this, help you out with any of your designs. If you want me to do a design for you, because maybe you don't have Fusion, maybe you're having problems with the spline tool, maybe you're having issues with your extrude, contact me. I'm more than happy to assist if it's not something overly complicated. If you don't have a crazy design size bed plates. If you're willing to put in the work, I'm willing to I can model for you, and we'll work out negotiation on price, etc. So that's it. Hopefully you guys get enthusiastic about these neon signs off your 3D printer. Hopefully you will take the chance and do this yourself. It is not that hard. Again, you don't need super sophisticated hookups. I have a soldering iron plugged into a wall sitting on top of a bench right now. I don't have all the fancy gear, and we still made it. It still works. So there you have it. All right, guys. You know the drill. Like, share, subscribe, follow. Let me know if you need any questions. Let me know if you want to see something new, and we'll catch you in the next video. Later.